Hey students, in this video we're going to cover properties of logarithms. All right, so our objectives are to convert logarithms to exponential equations and to review the properties of logarithms. All right, so first, we know the general form for an exponential equation is b to the f of x equals x. And so when we have a logarithm where we have a log base bx equals f of x, we're going to use that to turn it into this exponential equation. So when we have log base 8, 4 equals x minus 2, we're just going to take the base of 8, make the exponent x minus 2, and the power that we get is 4. So that's how we convert from a logarithm to an exponential equation. So pause the video and see if you can convert each one of these logarithms to an exponential equation. All right, so for A, you should have gotten 4 to the second equals x, and you can even go farther with that and get 16 equals x. For letter B, we should get 1/3 to the negative 5th power equals x plus 1. If you wanted to go farther with that, this would be the same as 3 to the 5th equals x plus 1. And if you know what 3 to the 5th is, which is 243, I believe. So 243 equals x plus 1. You can solve that equation and get x equals 242. For option C, or letter C, we get x squared equals 14. And then to solve this equation, don't be fooled. You would just take the square root of both sides. You would get x equals plus and minus the square root of 14. So when the base for a logarithm is just x, we're going to get a polynomial that we already know how to solve. All right, so now we have 3 properties of logarithms. You should have covered these in Algebra 2. We're going to do a quick review of these. First, we have the product rule, which is when you multiply inside a logarithm, each factor of the product gets its own logarithm. We have the quotient rule, where we divide, and each part of the fraction, like the bottom part, we subtract. And then we have the power rule, where if the function is raised to an exponent, we just move the exponent to the front. And we're going to use these to expand and condense logarithms. So for number 1, we have log. I should have mentioned, you should know this, but when we don't have a base on a logarithm, like if we just have log base x, the implied base is a base 10 logarithm. If you don't see a number, the base is implied to be 10. So anyway, for log x squared divided by y to the 4th, since we're dividing, we're going to give each part of the fraction its own logarithm. So this is going to equal log x squared minus log y to the 4th. And the problem is not over yet, because we have the expressions are not fully simplified, because the x and y still have exponents. So now the exponents move to the front. So we get 2 log x minus 4 log y. And so this is an expanded logarithm. All right, so you pause the video and see if you can complete 2. All right, so you should have gotten, if we go step by step, we would get log base 4, 64 plus log base 4 x cubed and plus log base 4 y plus log base 4 z to the 4th. And so for log base 464, 4 to what power is 64? That's going to be 3. And then the rest of these exponents just move to the front. So we get 3 log base 4x plus log base 4y plus 4 log base 4z. And that is as far as we can go. Pause the video, see what you get for this. All right, so for the third one, we have multiplication and division, and we have this weird square root x to the 7th. So remember, the square root of x to the 7th, we can make this a rational exponent, which is x to the 7/2 power. So what we're going to get is log base 2 32 plus log base 2 x to the 7/2 plus log base 2 y. And in the denominator, since we have a 5 and a z cubed, we're going to subtract both of their logs. So we have minus log base 2 5 and minus log base 2 z cubed. And log base 2 32, 2 to what power is 32? That's going to be 5. So we have 5 plus 7/2 log base 2x plus log base 2y minus log base 2 5. We can't actually do anything with that. And minus log base 2, minus 3 log base 2z. So that's fully expanded. Next, we're going to condense logarithms, where we're going to reverse all of these steps. So we're basically starting with this and turning it into a single logarithm. So first, we're going to move all of the numbers in the front, make them exponents. So that's going to give us log x cubed plus, this should be 4 log y, not like log base y. I don't know why that is. So we should get log y to the 4th, excuse me, minus log z to the 1/2. And so next, everywhere we add, we want to multiply those things. So we're going to get log x cubed y to the 4th minus log z to the 1/2. And where we are subtracting, we would turn it into division. So we get log x cubed y to the 4th divided by z to the 1/2. And remember, the 1/2 is the 1/2 exponent is the same as the square root of the thing to the 1/2 power. So our condensed logarithm is log x cubed y to the 4th divided by the square root of z. For 2, we're going to do the same thing. So we're going to get log base 3 x minus 1 squared minus log base 3 x plus 2 cubed. And again, since we're subtracting, we're just going to make a single logarithm and divide the two terms. So x minus 1 squared divided by x plus 2 cubed. And that is our condensed logarithm. And for the last one, we're going, you can pause and come back if you want. So we're going to get log base 5 2. And first, so the things that we're subtracting are going to be in the denominator together. So we can, we're going to multiply those at some point. So we're going to have minus log base 5x. And then this 2/3, that's going to be the square root of x minus 1 cubed. So we're going to have minus log base 5 x minus 1 cubed. And we said the square root, that's, I'm sorry, that's the other way around. It should be the square root of the cube root of x minus 1 squared. My apologies. So now where we have negatives, these two things should be multiplied. So we get log base 5 2 minus log base 5 x times the cube root of x minus 1 squared. And so then, because we're still subtracting, we're going to get log base 5 2 divided by x times the cube root of x minus 1 squared. And that is going to be our condensed logarithm. All right. So that concludes this video on expanding and condensing logarithms and using the power rule, and also turning logarithms into exponential equations. Thanks for watching.